Dear colleagues, Vladimir here. I'm recording part two of developing agent harness called Whale. And the last time what we did, we initiated the process. We defined the glossary, the specs, definition, DevTools, design, commands, configurations, other important things. And we were able to succeed in building the building the first command to be able to act and to work. And so we continue here. What we're gonna do is to step back a bit and spend some time on the specs and in particular the architecture. In our team effort, we discovered that the architecture is very important. And there are many harnesses. Some are more performant, some are more prominent, some are less performant. But if we looking for and thinking of to move the things forward to the state where we discover something new or we create a more performative harness, we need to look deeper. We need to think of the architecture. And so we go. I mean, usual architecture as we standard architecture with this recommended by LangChain is React. Well, not React architecture. No, no, not no. It's React. Okay, agentic AI. So yeah, there are many guides like this. Like what is React, how it works. The one from LangChain has a good explanation. And so, okay, but we need to come up with, okay, I'm still not happy with this definition. Let me find a better one. Maybe this, maybe not. Okay, let me maybe find the image. Okay, this is, I guess it's okay. Query, LM reason, tools call, environment, memory generate. Okay, it's and basically looping over it. And so, okay, but we need to think further. There are, guess, upon these nuances, a lot of things depend. So, what I propose here, or at least let's start with this hypothesis. We pick up, basically remember what was before, also known as retrieve from memory. Then we need to, we kind of need to also learn not just retrieve. Maybe we can run a cycle, or maybe we can run like kind of sub loop, a loop to kind of to have a high level understanding what was before. Then we have to, we need now, okay, knowing this, we need to plan. And ironically enough, we can like also run, well, when I say x100, then we can also loop over the plan. I mean, why not? Run a loop to iterate over planning. This includes uh, spinning up the agents to plan. Why not? Maybe we can have a plan with tree like structure, uh, tree like structure. Mm, that we structure, basically tree like graph. Also, certain memory, we'll get there. I already have some, you know, tools prepared for first reading of this. Okay, but the plan itself is not sufficient. Maybe we can research further down the plan before we act. Research further down. Mm, and I mean, we in plan, we also we think we imagine we can spin up the agents, a kind of a swarm, and for research also with the swarm of agents. So we're building a multi-agent system where the agent is generated dynamically. Maybe it should be a building. Okay, let's state this later. Uh, then we have, okay, so then we have execute. Execute the plan. That means produce the output for the user. And it can be also done via the swarm. By the way, let's add this to glossary. Multiple agents working in parallel, executing a piece of instruction from the system or the user. And again, maybe the tree is not the best structure here, but we will think of it a bit later. And so via swarm again. And then, of course, here it's also the moment that would differentiate what we develop in here from other harnesses, maybe not. We need to don't remember the formal definition. We need to loop over kind of, let's add a kind of this functor, high level functor. And but what is in and out of the loop over? There might be many. So we pick up, learn, plan, research to force the plan, to enforce the plan, to strengthen the plan. Mm. Execute the plan, produce the output for the user via Swarm. And I think there is should be a reconciliation from the first three phases, I believe. Let's enumerate them. But again, enumeration, it's also assumes some kind of blind spot down there. Because we might be better off interchanging the steps. Okay, but I think here we say register success and back to the memory. I think we're here. Let's move it to organic, to the natural position. Natural. Assume natural position of this. Record. Register the success. At this point, let's not be time bound. Let's just think that we register the success. We have a positivistic hypothesis that it will execute the plan, it will loop over, it will produce the results, and the output will be available for the users and will be matched to the initial one. Register the success. Fact. Basically, let's just register the completion fact, not call it success. And then matched it to the initial plan with pickup, with kind of remembering, with the memory, retrieval from the memory, and learning and planning. And or even with the research, because initial plan, because the research strengthened the plan, but it itself might be faulty. Guess we match it to the initial plan with or even maybe maybe we will have all this shrink down to one step, and we will be looping over these three. And I think matching to the plan that was created, it's okay, but again, here we might not have the trust for what was planned. But anyway, tuition fact, save the output, match to the plan on step 3, at least at this point is step 3, and then decide. But here is we need a mechanism called LLM as a judge, which itself might be problematic, but let's just keep it like this, decide whether provide the output or let's know this, don't remember the exact sign of this, so say go to loop over. I think it's something like the output. There are 3 paths, maybe like this. Where there is a pipe and or go loop over. Okay, I think this should be it. And of course, there are nuances of like how the agents are created, how the tools are created, what would be the tools called, etc. And you might wonder why we spend so much time on thinking on these stuff, things. Can we just like basically take whatever is there and and to just repeat it and then see? Yes, but first we need kind of grounded understanding of what's happening. And that's also part of this journey of creating agent harness. Of course, you can just like vibe code it and it will generate the assumptions that are already there. And I would also spend some time. Let's do two things in parallel now. In one thing, we will launch opencode and help us reverse engineer the new harness from DeepSeek that appeared. Well, it says it's relatively recent, okay? At least they say so. DSP, DS hash. Okay, so we'll ask opencode agent to reverse engineer that and see. And then we'll also see and inspire from Hermes agent. Okay, excellent. And then let's do, let's call it, we have a doc called power specs. Let's have another one. Plans, not plans. Doc sounds okay. Let's create a new folder called other. Then say, let's do like this. Can you please clone this into temp? Run three commands. Read the code, read architecture, compare to our readme, and then this architecture, and then let's create Hermes architecture, and then readme and write the architectural facts like type of the agent DAG React nuances, agent swarm, etc. Here. Okay. Okay, not exactly here. I want it to be moved here. The docs. Move. Yeah. Okay, nice. Okay, I believe this is a good prompt. And okay, let's go. Uh, and then let's do the same with, okay, I just need to launch another opencode instance. And here, okay. Okay, okay. Okay, I want it to be visible, but anyway, let's just modify it. Can you please GitHub and let's specify, okay, this one. Okay, we do the same for Hermes agent. And let's ask it to save the result into this. Okay. Nice. Let's go. Okay, it's running. I think it cloned it into temp directory, and we will get results soon, and we'll read it closely. Nice. Okay. So let's get back to the architecture. Um, architectural aspects. We said that we have multi-agent, memory semi-structured, maybe right away it can be LLM wiki type or semantica. It's the new tool for kind of uh, ontology graph-based representation of the knowledge. I don't care about AI much, however, it might be useful. But we probably can use it as a memory agent, sorry, as a memory middleware. Let's not hurry up. However, it structures the memory really great in a way. What is semantica? Semantica is real end-to-end pipeline, not a single binary with marketing. Okay, thanks. Every stage below is a shipping module, independently importable. Okay, and so when we read it here, all it does is ingest the files, remember, structure this. But interesting how it looks. Does it has mechanism to kind of create higher level graph automatically or not? Um, well, it definitely does has a pipeline and does a great job of ingesting a lot of data and creating again ontology based. Ontology is like a XML type of structure where you have definitions of entity, classes, actions, objects within, and structure. It was a big deal in 90s and 2000 to have to be able to build a very say reality based knowledge base and then maybe make UI use it. but it's in a way failed because it had to it was kind of hard to maintain it, and it's still in the academia or in a lot of R&D places, but it's not as vivid. They now adhere to a simpler structure like XML, JSON, maybe semi-structured database, structured data, and like structured database, etc. And like what felt like a excess back then. Okay, so this is a big machine. Uh, let's semantica. And let's look at the LLM wiki, which is a simple knowledge presentation and it can be self-learning in a way. Mm, Assistant wiki, yeah, it's also basically has a kind of learning mechanism. I filtered each chapters ago, building out pages. Okay, it's basically pieces of memory, pieces of text structured in a wiki-like, book-like manner with particular indexing. And needs to be also, I mean, okay, they say that there are like learning loops additions on top of this. What is this, by the way? Okay, it's a guy who is CTO. He does a lot of memory tools and agentic harness, and this particular one. What does he mean here? Okay, it's also on. Okay, it's a guy who continued this idea of this Andrei Karpate, and he also puts a stake on the Sansra with some important benchmark too. Okay, so he's also built a knowledge base, but let's see if it's let's record this, of course. Maybe specifically this piece. Learning loop, staging, distraction, distillation, review, promotion, tension. Wow. Mm, we need to read this definitely. Let's save this to further reading. Maybe we take this looping idea and one step back to see what does. What were that? Okay. Interesting. This guy says that he really takes the learning further. In which way it's depends. Um, hmm, then it might be contribute. Okay, let's. This is nature don't materialize it, and he doesn't materialize the contradiction. He really takes the learning and puts it down. And he said that in his knowledge base, it's important to just start with the entity. Okay, very interesting. But this semantica seems to ingest this perspective too, where it's kind of in their pipeline, they say they parse, they normalize, they dedupe, and yeah, duplication. Mm, they have temporal graph, temporal graph, wow. Facts, and then connectors, okay. And then some, ontology kept. No, I mean, that's cool probably, but it's so hard to kind of embrace this. It needs a research of its own. So, I mean, it feels like on the first reading, it feels like a knowledge graph with ontology, also kind of with some learning dedupe capabilities at scale. Let's save this. We get back to that. So, let's see if our agents did a great research. Oh, okay, it needs it's stalled because it requested some permission. That's okay. Let's go. Okay, and this one seemed to render results. And then let's see. Okay, shallow clone, finger crossed reference against our own README. Hermes is a single agent tool calling loop at the core with two orthogonal fan-out mechanics layered on top, mixture of agents, advisory parallelism inside the model call, and a single level subagent delegation swarm outside the loop. It is not a deck planner, not a React paper faithful implementation, not a multi-agent framework. In the line graphed out stance. It's a pionated, narrow waist runtime. The core loop is simple. The capabilities surface, like skills, plugins, MCPs, tools, platforms, is huge and lives at the edges. Mhm. Um, uh, to be honest, it feels like not the cleanest code, and especially this monolith. It feels like it was pipe coded, which itself is nothing bad. But it's so big, like 11K lines of code in agentic class. Wow. Agent conversation loop, main loop. It has a loop via conversation. Companion sourcity. Wow. But uh, auto discovery tool files. The auto discovery tools, don't remember if we had it. Mm, where we have tools capabilities. I like the term here called capability surface. Let's reuse it. Okay. Oh, we have it kind of capability surface. And auto discovery of rules. Interesting. Okay. And there we have not here. Repository effects. Okay, we read that. 17K tests across 900 files. So it's like probably unit tests, mini integration tests. Won't look into this further. Guess it was developed on the assumption that if the test passes, then it goes. Okay, not sure, but let's read further. Agent loop, what kind is this? Very simplistic, to be honest. Single agent iterative loop, not React. Not a sub-agent iterative loop to use, not a graph, not a MRKL. One graceful concession bounded by max iterations. Yeah, okay, caps. Caps should be there. Iteration budget, cost ceiling, interesting. Need to consider this. Run budget. Message in the cache save way drops. From caching, it's sacred. Per agents, the policies shape almost almost every design decision. System prompt and tool schema are byte stable for the life of a conversation. Mid conversation invalidation of the cached prefix multiplies cost. Okay, I guess the savory design that they develop is quite cool. But I think it's a bit overhyped, all this tool, but let's not do what they call snap judgments. Wrap-up notice appended to the newest tool message, not injected as a new synthetic user message role. Termination assistant tool, assistant is a thread as a hard invariant. Never the same role message in a row. Never synthetic user message injected mid-loop. Okay, these savory tactics are cool, but here I would question if it, pushes good enough. Maybe it does. Okay, let's see. Sub-agent delegation. Delegate task tool exists in the delegation toolset. Quotes from this module docstring. Spawns child AI agent. Okay, if it's child, does it mean that it's tree-like? Every child receives friend conversation on parent history, its own task ID. Okay, no, that's cool. File ops cache. Parents tool set with child blocked tool stripped. Interesting. So they pass the they pass a dictionary, a map of what tools to use, of what tools not to use. Smart. The parent context only ever sees the call and return summary, never the child's intermediate tools, tool calls, or reasoning. Block tools in subagent. Child cannot recursively delegate, cannot ping the user, cannot schedule work, cannot direct message across platforms, cannot mutate shared memory. Okay, so they have kind of piece of memory isolated, piece of tools isolated, piece of memory isolated, limited number of tools isolated. Okay, interesting design decision. Roles, leave, default, focus worker, no delegate task, no clarify, no memory, no set message. Keeps execute code, programmatic tool calling. Role orchestration retains delegate tasks, so it can spawn its own workers gated by delegated orchestration enabled, max spawn depths. Okay, so it's to level 3. To execution state, single and bash parallel is running concurrency and kept at max concurrent children. Okay, so there is depths and there is concurrency, which is 2 by 2, 2 by 3. So it's like depths x concurrency 2.3 at a time, I guess. Loop for every claim, background delegate task is detached from the current turn, but still process local. For the works that must survive a restart, Hermes routes through cron job and terminal background, notifying completion through. Okay, interesting. This might be a good inspiration. Let's write it down. Oops. Agents and tasks. This is a single level delegation tree, parent, children, parent, children, parent, children, parent, children, parent, children, not transform in the sense of many autonomous peers selecting a leader or gossiping. Parents, so always on the loop, children are leaf workers, one level down orchestrators. Well, that's interesting. But again, I wouldn't treat this as an ultimate source of truth. There might be other aspects in other architectures that might be more performant, and we want the great things at hand, don't we? Then, mixture of agents. Mixture of agents, okay, pre-iteration enrichment, not a replacement loop, which modeled fan-out and reference advisors models in parallel via thread pool executor. Each reference gets a different system prompt, advisor review, redact. Okay, so they have kind of save traces for mixture of agents. Okay. They have Kanban or queue, durable SQL backend board that lets multiple profiles, workers collaborate on shared tasks. User drive it via LMS Kanban. Verb, workers spawn by the dispatcher, drive it via dedicated Kanban. Okay, this persistent memory kind of accessed as a collaboration surface for collaboration, like board for the agencies. Looks great. Interesting how they presented in MySQL. Guess we won't have that much time to research it in depth. Hard boundary board, respond the Hermes Kanban board. We can see the board, okay. Subboard tenant, one specialist flea that can serve multiple businesses with workspace dispatch, memory key isolation. That's interesting. Dispatcher, a long-lived loop that reclaims stale claims, promotes ready tasks, automatically claim and spawn the assigned profiles, run in the gateway. And if I read this correctly, happens within a kind of once agent loop with depth 3 concurrency, depth 2 concurrency 3, and everything gets saved to this Kanban board, which is stored in SQLite as a memory backend. Okay, that's quite smart. It feels like that it's designed for very broad orchestration and the broad workflows where you can, in theory, have, say, call on packs of agents that do automations for departments for like the whole business processes, or do continuously, say, R&D in certain executions and keep track of what's happening. Maybe it's kind of designed to make use to kind of have a very structured memory. Sorry. And build up bigger pieces. Okay, and memory. Okay, but isn't Kanban the memory? Classification, asynchronous, work queue, orchestration. Okay, it's work queue, not an in loop. Deck planner, okay, whatever. Task goes through state transition, create, block, review, complete. But the runtime model is durable queue plus spawn dispatcher, not graph executor. Quite important, okay. Uh, agent curated memory with periodic nudges, autonomous skill creation after complex task, okay. Skill self-improve during crisis, okay, that's important. So yeah, why don't we just improve the auto discovery of tools? Auto creation of skills, maybe even MCPs, because it's like fast forwarding. We can do via loops, I guess. Concurrency systems, Bocho, mem0, super memory. But I mean, you can select all of this, so it's discovery is bundled first, reverse of the general plugin system. Precisely. So a drop-in user director can shadow a ship provider. Periodic nudges, okay. Skill self-improve, interesting. Session arch, like 5 500 590k line session TB. And then what happens? It disappears. Honcho geoletic user modeling keeps a two view of the user self model versus the agent's models of the users. Oh, wow. Interesting. about why this important. But let's see about Honcho dialectic and session search. Okay, but it doesn't what why separate session is needed if it's already kind of arranged in the memory? Can it be arranged in the memory right away? Let's read this, and I'm also interested in retain TB. Retain DB gives just durable memory decision, preferences, workflows, corrections, project facts, session headoffs that survive across conversations. Interesting. It's like I guess it's like a memory for generic purpose memory to profile you. Company brain. What else they suggest there? Supermemory Honcho. This Honcho dialectic is for dialectic specialized LLM agent and API layer. Honcho. It's memory infrastructure for building stateful agents that understand changing people, agents, groups, projects, ideas over time. Store messages and events, let Honcho reason in the background. Then query peer representation, session context, search results, natural language insights from any model or framework. Use it managed, thanks. We don't need it managed and self-hosting. Mhm. Um, Honcho loop. So I want give my coding edge persistent memory and member to my product. So okay, understood. This one hosting the core service logic implemented test API. Honcho peer session. Okay, and this is used there in for kind of representation of the users and of the agent. Look, I mean, okay, there I think it's clear we spent quite some time on this. I guess we need to also see what's happening in DeepSeek for NAS and then return to our architecture because we can't go on like this forever. Okay, let's help opencode finish this research, then we read it quickly. Okay, I would go our to our setup. So, okay, we defined that was quite useful. We saw how how it orchestrates, how it uses memory, how it stores the representation, how it keeps the things that they created, which is Kanban board. It has some useful, auto discovery of tools and bundled infrastructure. Auto discovery of tools, auto creation of skills. These automations are cool. I think here, I think it's via hooks. Um, and then, but Okay, we learned certain things. We won't replicate, of course, what they have, and because I believe they are too big to kind of to ingest, and they say that it's quite powerful. Some say it's overhyped, and I propose we looked at the semantic with graph. There are like other boundaries which you can bound things by Kanban. Board always still doesn't make me happy. I would look into, instead of tree-like structure, I suggest we use directed graph with has a loop, but it can, I think it should resemble some like more like rhizome rather than, which is also a graph. Mm. uh, rather than mm, what other things offer. And in the rhizome, thing is, this representation are not perfect yet. Uh, in this manner, everything might be or might not be connected to the next one. And it has a temporal component, but its temporal component might also be treated uh, as a separate dimension. Mm, I wouldn't spend that much time on the math on these concepts here. Uh, uh, there is, so much there. You can create you can basically, yeah, there is like rhizomatic ontology. Mm, some pieces are not hierarchical, some are graph directed, and then it is there. And now I'm like thinking, should this be, mm, let's correct the mistake, it's spelled like this. Should we keep the memory in the rhizome, or should this be a modus operandi of the agents that we spin up? And in this manner, we are okay. Here we're feeling the ground might not yet be there. That here we actually trying something, you know, something new. Maybe it exists, maybe not. But I mean, here we try something not that obvious, and we looked at other architecture. Let's take another one. Let's see if this completed. Yes, completed. And then, okay, let's see what DeepSeek architecture presents. Okay, agent DAC topology. What kind of agent system is this? It's not a single DAC. Harness composes several distinct layers topologies. The clean way to read it. Fundamental unit is session log. Session event start. Okay, it's session based. Turn step and request to calls next step. It will continuation to send. Okay, that's interesting. It's a mini loop. Turn is 0 or more steps. A step is more model request plus tools. It is called. We also act, observe, decide, repeat with the exit criteria maps cleans onto the DeepSeek harness. Step tool, next step. Okay, but I'm not exactly planning act, observe, decide. repeat. I want something. No, maybe I still, yeah, truth be told, maybe I'm still within this paradigm. But I want it loop based, and I will want it with learning, remembering, learning, researching, and bigger loops, and rhizome and graphs. Agent is a node holding one session. Hierarchy is expressed in a tree rooted at one late session, with the three edges recorded as durable session handler. Team ID is a root session ID under a distinct brand. Team implements directed cyclic task duck. Blocked by edges must remain a cyclic, acyclic, layered over continuous, continuable subagents. Okay, that's closer. It's on the very first reading. It feels it's closer to what we're developing, to how I would see the AL agent, whale agent. Roster continuable children. Okay, long-lived. The parent owns them and iterates over them. Multi-provider fan out. One switch delegates. Then spawn, forked, act, codex. One shot subagent has sibling nodes. They live in parallel with the other siblings, but have no inbox-based durability. They are fire and collect runs that resolve to one subagent result. So it's the children who do kind of tool calling name providers. Um, but, it's these are different types of child, I think. When you kind of call these external tools interagent, a cyclic agent, tree on a durable parent of relation with a deck of task building teammates. It's not a free-form message passing mesh. It is and it's not a generic cognitive duck like cognitive duck like line graph code, but not a declarative graph wiring. Choose topology per spawn. It reveals topologies. That's smart. This is a step loop, not correct. The body of every step is assemble, agent, assistant, tool call, step in. Okay. The model produces structured tools. Okay. Automation tool creation. We capture that. Hard pre-step policy, cross-step waterfalls, steering, inbox is a durable queue. Inbox is a durable queue. Every pairing message has identity messaging key, lives on next turns, next steps, blah, blah, blah. Claimed by agent inbox. Interesting, this concept of inbox. There is no separate plan act react phase, and each planning is a separatable subsystem. Packages plan that surfaces a plan mode over the agent loop rather than a second loop engine. Okay, nuances. There are design choices that matter for comparison with Whale. Okay, but it's still kind of, they have a minimal, I see now that the DeepSeek harness has a minimal learning loops. And okay, we also, what we created in our plan resembles what they do. But let's see further. Okay, everything is a plugin capability sim. A capability has three roles: service definition, vocabulary, service provider, consumers. Okay, we discussed that. Append only session log plus append only roster. Okay, so they have session and then they have call ID, team ID, call team ID and message ID probably. Plugin authors extend some types with TypeScript declaration merging. Okay, they throw in the plugins during the session. Okay. Maybe it's really important to control the tools and the plugins that you call. And make sense of it. In nuances, they have swarms, teammates, a cyclic graph, again, subject description, and it reiterates over. Team ID, it kind of does it spawn sub-packs of agents? Membership is one root. Important contrast. Root domain. Agent team is experimental. Private opt-in. Document is agent teams. Agent teams. Teams are not the default Horness mode. Deep-sea Horness and fundamentalist agent-centric teams are coordinating layer of continuable sub-agents on top of the same CTX agents. One-shot delegation related to the same. Spawn, in process, fork, agent client protocol remote. Context, okay, whatever. Architectural facts. Profiling bundling, bundling. DeepSeek is a plugin to recompose the bottom from ordered layers. Okay, understood. Presets. Ralph. The fresh agent Ralph loop is a model-facing tool policy composed from workflow sub-agents primitives with the same session goal, not an agent loop mod. To be honest, I'm irritated by this. Not this, not that, not this, not this. Not a scheduler. Ralph rounds a fresh sessions, sharing a workspace in the normalize bounded structured handoff, different from continuable subagents, which persist one session across rounds. Turn step user message tool. Okay, that's clear. Okay, that's clear. Okay, it rushed out to was directly comparable. It's rushed out to the conclusion, but anyway, British wins deterministic sims, plugin composability, durable session log, scope, but we will have all these too. British is silent, self-evolution, ontology memory, dynamic tools creation by in-loop subagent. You ship this by writing a plugin. Well, tree like plan is like self-learning goal would map to a plan mode plus a feedback learning plugin on top of the same scaffold, not as a new quorum runtime. Thanks for reciting for me, but we'll see. True, like plan and self-learning goals would map to plan mode. Okay, maybe okay, let's go back to our step. So what we learned, these are fundamentally different harnesses, DeepSeek and agents. this harness is Hermes harness is targeting persistent memory with some states, with some boundaries, with mini loops, while DeepSeek harness is kind of classic React iterator with plugin system, fire and forget tool calling, plugin definitions, session based, and haven't grasped if they have a bigger kind of what they and agent teams, interesting concept. Maybe we should also deploy that. Mm, they have kind of some QUs, they have swarms, teams, spawn teammate. Everything is kind of a function calling, tool calling for them, and it has some dynamism, and probably it uh, uses all the steroids, whatever it can find in the system. But okay, thanks. That's all good to know, but I guess we have to go continue with what we have. I think the architecture that we design is okay. Specs, it's okay. Structured memory, swarms, stop criteria, self-learning, inspired by, but okay, her message is not kind of self-learning in a way, but let's just remove the claim that it's inspired. Should be self-learning, should have tools available, as many as possible. Dynamic creations, yes, we can, not, it's not a maybe, it's just a fact. Loops we mentioned, self-learning, important. And I would let's unite maybe into all this into the specs, as we have started to have repetitions. Powerful and simple learning capabilities. I would still, kind of asks for arithmetic-like structure. Mm. Here we will do two things. I think this will be challenging. Memory is challenging, and this arithmetic always sleeping and nomadic-like structure should be first formalized, and then seeing how can be applied. But let's start with simple one. Let's enable at least some kind of memory. By the way, in important addition to the design, I would add something like apps. Basically, it's equivalent for apps, add, and then the type. Or use apps, because if we manage to, maybe here we also have agents, default, custom MCPs, tools, settings. Maybe we will have something like apps. Then we have OUs, apps, JSON, and then maybe have kind of, well, not pair, talking how else you can authorize connect. Because like, I mean, instead of, if you give a specs and AUs specs, maybe kind of, and then can have open API. Sorry, docs at specs. Memory sessions, etc. Again, we might be using the semantic. So, okay. Sessions, do we have a place to store sessions? Yes, we have. Maybe we can say have session ID. Let's have a simple structure, then we will see. And memory. Okay, then let's back to the concrete one. I think what we will be able to do, we did a very, very big research here. I think we can at least initiate a memory or make sure we have replayable session and replayable memory. And then we will try to save the memory to make the memory always self-learning and see how can it be mutated and learn new things. So then we will need a kind of way to manage this memory because do we have this? Maybe not, maybe yes. Let's add the sessions and memory or like memory. Mm-hmm. And then we probably have the comments like forget something, relearned, add something like this. These hooks should be called automatically. Okay, we have, and then we have memory manager. Just let's have a tool called memory. And once the back would, okay, I would erase this. I don't need this. So we need to be able to call to auto update the memory. Maybe we can have something like hook. Uh, I'm like writing I'm writing some pseudocode here and then we'll ask the agent, so far not ours, but we will get there to hook record, and then maybe we can create an abstraction like just a single hook. But what would be hook record and hook retrieve? Interesting, but this would be also kind of a tools then, and then we end up with the everything is a tool, and then we like stay within the DeepSeek paradigm. Anyway, let's code, and then we figure out. I will task this one to be able, and then we already kind of let's search through the commands. We had the command kind of Python, how we call it? UV main. This one. This will be that we prompt directly the model, and it should be able to record what we just said. Okay, let's first add. Remember what we have. Sure. Agentic architecture research, improving our architecture. And so, like we remember engine, and let's spend some time here. Is like or maybe should we also initiate the session? Yes, guess. Let's say have a session. Here we have a session manager, kind of new session manager. Init session as default current path. Store append a message to the session, I guess, to the session. And the session and then the interesting question. Okay, it will be stored to the system and list session list. List session, append to session. Session. Maybe load to init session. No, load session. Session ID. That's just okay. And now it's okay. Let's just finish this. See if the sessions are needed. See if we just prompted. Let's just save it. But okay, no, it's not. Please logically finish loading this one. No, we can. I know it's quite obvious, you know. Be concrete and brief. Oh, we don't need full pass here. Concrete and brief. I would then use then use the hooks. Use the hooks in Default prompt. In here. So the goal is to still to be able to prompt, just like we did before, but now to have it stored in the memory and have the session initiated. Okay, let's wait for a second. Oh, okay, interesting. Okay, you did it quite well. Session manager, load session, init session. Oh, okay. Okay. Interesting how it will implement the memory. Okay, it seems does the same, but it will be primitive, of course. Nice. Okay, but it's good enough for the start. We of course then basically be going to invent this self-learning rhizome-like mechanism. I didn't ask to write tests, but okay. So, memory. And message is session memory hook record. Session ID, response, hook record, prompt, text, response. No, not ideal, but let's try this if it works. Okay. Do you know how to code? Okay, let's verify if what's there. Mm, uh, so let's go to probably to dot whale if it's created. Okay, it's there. Logs. Oh, logs memory session. Let's go to memory. Not exactly what I wanted, but at least it hooks up to the memory. Oops. Uh, Box. Okay, cool. This session cut. Okay, then we can maybe, we can, do you know how to code the role assistant? Okay, but you know what? It's okay so far, but I think in the memory we should be able, maybe it should be, we redesigned it into a cron job. Or we can redesign it in a way that it's maybe it should be kind of it reads through the station in raw material, then it writes back to the memory itself once in a while, because it should remember basically the high level stuff. But this how it's done. It's done with a prompt, or maybe in every kind of iteration we ingest a particular structure, we ask for the LLM to give a structure for semantica. And in semantica, we would, let's just record next steps somewhere. And in semantica, like we ask, like here, current progress, we recorded here, implemented architecture, research. What date is today? Today is this 20th of August. Implement architectural research, memory hooks, session init. Okay, so far good. Next steps. Proper memory arrangement. Ideas. Always ask LLM to return a prepared graph graph object as we intend to have memory of graph structure node or branch. And save it immediately. Or we fire a tool call with fire and forget option to form this graph primitive, let's call it so. Okay, so that's basically we recap that. Thanks all for your attention. Please like and subscribe. That helps me stay motivated and produce new content. And hope it was this session was useful. We spent a lot of time researching other harnesses, reflecting on our own architecture, and time will show if we came with any brilliant ideas or harness will be performant, which is our goal. Well, at least we hope it will be original. Thank you. And the journey, of course, is worth that. Okay, thank you. Bye.